if anyone's going to send it to Mars, then it must be pretty reliable.
So, this is a bit of a strange one because usually Guy does the IP experiences, but things happened and I'm on this one for Red Pitaya. I know that we've built them as a single board computer and a replacement for all your scopes and stuff in the past. I could not have been more wrong in how much I've underestimated where their product could have gone. Prepare for an interview that if you want to know about the applications of Red Pitaya, you'll be speechless.
Hey everyone, it's Eamon this time, doing the IP experience. We're at the ipXchange studios here in Hayward Heath, England. I'm here with Nicu from Red Pitaya. So we've talked about Red Pitaya before, but they've got a new board out. So Nicu, for those in our audience who haven't seen any content on Red Pitaya before, do you want to just explain what Red Pitaya do?
Hi. So I'm Nick. I'm product manager here with the Red Pitaya team, and I'm really happy to be invited to this discussion. Sure. So Red Pitaya, it's a lot of things in one small package. That's why so many people from different areas get attracted to it. To try to put it in a short form, it's a small form factor computer with a high-speed measurement capability. It's a programmable board. It's easy to embed in bigger projects board. And let's say the secret sauce of it, it's mainly its speed, right? So it's a tiny board, tiny FPGA board like this that you can connect with the Ethernet cable here, and that can do 125 million samples per second, 2-channel in and 2-channel out at the same time. And because users can program it in a lot of languages, actually, including Python, LabVIEW, MATLAB, C, and so on, it's very versatile. It applies to a lot of people, to a lot of projects, and that's why we see them all across the board. Maybe we will mention a few during our talk today.
Cool. So I remember when I chatted with Mika at Embedded World, he had it set up as a bunch of different scopes. So is that the main application?
Yeah, so actually I was developing and building all the demos that went there. We had 2 booths, actually. I was on one of the booth and Mika was on the other. Well, we can do many instruments in one interface, like oscilloscope and signal generator is just one of them. We can do spectrum analyzer, we can do vector network analyzer, we can do many things out of the box. However, we noticed that the oscilloscope signals are the most common that people get attracted to. So the demo is just for attracting attention, right, on the trade floor. Yeah.
Just wondering, with that number of samples per second, what frequency do these go up to in terms of? Because I mean that's definitely RF and above.
Yeah, we have a few models which differ in specifications. The let's say most popular board has the range from DC up to 63 megahertz.
Okay,
right?
Cool.
Yeah. But for instance, we have one model that we developed because we noticed that some of our customers, I don't have it here on my desk with me, but it kind of looks the same in the overall format. Some components on it are different. So what we did, we noticed that our customers were hacking the most popular Red Pitaya unit so that they can use it for SDR purposes, right? Software-defined radio. So what we did after a while, we noticed that this is happening a lot, and we sent out a survey. We asked the ham radio community what would they like, and we developed one tailored unit just for them. And it has a little bit different specifications. Overall, I would say it's kind of a better unit because the processor is bigger, and that drives the cost just a tiny bit. And that unit, for instance, can go from 300 kilohertz, and it's open to 500 megahertz, 550 megahertz, right?
Oh
and,
wow! So almost 10 times the frequency.
Yeah, but you have to understand that, like usually RF engineers, they know this. You cannot sample more than 60 something megahertz and get a reliable signal unless the signal is periodical, so it's repeating itself, right? So
because of aliasing.
Yes.
Yeah.
So you kind of have to know what you're doing if you plan to do undersampling. It's called. This is like a technology to measure signals which are higher in frequency than what you can do, right? Yeah. But still, 125 million samples per second, it's more than enough for projects with LiDARs and radars, like even new types of radars. I have seen a couple being developed with our little board.
Cool. So you've mentioned radar applications. You've mentioned software-defined radio. What's kind of the broad scope of applications that Red Pitaya have found themselves in?
Oh, it's all over the place. I think maybe if I would be to write a list somewhere, we would get to the conclusion that it's better to mention the areas where we are not, or something like this. I have seen French institutes counting fish in the ocean.
With Red Pitaya?
Yeah.
Wow.
The NASA guys, they are measuring the air quality inside the space station for more than 5 years with the same Red Pitaya board, but of course they program it to do something else. Yeah. By the way, do you know how they were measuring the air quality before us? They were bottling up the air and sending it to Earth. But yeah,
wow. Okay.
That's another discussion, and yeah, we can talk about the feedback time.
Wow. And I guess if when the Red Pitaya board's there, you just get that kind of data instantly, pretty much.
Yeah, it's all over the place because it's a really fast digitizer, and because it's like open source software, everybody can have access to it, right? It almost doesn't matter the budget because they can do it. More interesting ones, and I hope nobody will come to me and ask questions because I'm really not a specialist, for instance, in quantum computing. But this is like
that's really funny you say that. So my background's in quantum computing.
That's great.
And I was thinking, oh, we could have used one of those.
But they really love our product, to be honest.
Yeah.
And like I said, laser stabilization, I think this is somehow connected to the quantum computing. Sometimes our customers are like really happy to share what they do, right? They say, hey, that would be great if you can talk about our project, what we were able to do, because it would bring us investors, right? It makes sense. It's also in their interest. And these are the projects that get published on our website in the blog section.
Okay.
We have like categories like academia, research, industry, and so on. But there are other cases like new technologies being developed where people can say, okay, we are not making weapons, we are not making other dangerous stuff with it, but we can't really tell you in details what we are working on. And after a few years, we usually find these guys in the patent office documents.
Nice.
Yeah. Because this actually happened. If you search even now, you will see a lot of patents where bigger medical machines used Red Pitaya as a digitizer inside of them to, I don't know, study stem cells or all kind of disease early identification, diagnostic machines, stuff like this. So yeah, I mentioned radars. Even earlier on, one team of students from Spain was measuring the distance from the tip of the blades of the jet engine to the casing.
Okay.
with the laser and the Red Pitaya, right? You cannot go there with the ruler while the jet engine is working, because that's the a big factor in motor efficiency. Right? I'm not like a specialist, but this is like what I know. And in the nuclear field, we have a lot of detectors for using Red Pitaya. I'm, again, not an expert in that field, but maybe we are so affordable that they use the digitizer from us almost as a like a disposable instrument, right? Because in nuclear, they bombard the things until they don't work anymore. And yeah, it's literally from the bottom of the ocean until the sky and beyond.
Nice.
Actually, sky and beyond. I just remembered. Do you maybe know about this Mars helicopter?
Oh, yeah.
So
That sounds
the
familiar.
NASA guys, JPL guys, they made a square-looking helicopter that flew on Mars, or maybe it's still flying because it was like really good. They are, I can tell you this, they plan to make a new version, so the second version of the helicopter, which is going to carry one of our products, and they are going to use it as a ground-penetrating radar on a Mars drone.
Oh,
So
that's pretty
how,
cool.
how cool is that, right? And yeah, that's one of the biggest things I would say that I'm just waiting for the stuff to get out. They
Cool.
send
So
us
Red Pitaya could be on the red planet before we know it.
yeah.
Wow.
So yeah, it's truly versatile. It's truly versatile.
Yeah, that sounds like it goes far beyond. So when I was reading up about Red Pitaya, I kind of saw it as here's basically your lab's worth of big scopes all in one place. But this really is much more than that. It's
This is how we were advertising in the beginning to the students, because the prices for the lower end was I would say in the budget of the students, right? And we were saying something like all the laboratory equipment in one tiny package, right? The Red Pitaya. So they have on their desk the oscilloscope, the signal generator, and even the ability to program it in Python to automate stuff. Combining multiple instruments, right? Because it's not like when you use the signal generator, you cannot use the oscilloscope. No, the oscilloscope, the 2-channel data acquisition and the 2-channel signal generation and the 16 digital I/O pins for logic analyzer, these guys you can use all at the same time, right? So it's really good for making your own applications. Like one of the most interesting I've seen, it's the PID application, right? So we put out a set of tools, and then we noticed that somebody made for control theory, they made a PID application, which is not difficult to implement. They needed it, so that's kind of another additional value. They are able to make their own virtual instrument, if you may.
Cool.
Yeah.
So in terms of the new board, what does that bring to the table?
Yeah,
I see that it doesn't have the connectors already on it.
Yeah, so the new board is nothing like crazy innovation or something if you take a look at it from the simple perspective. So here's the like a traditional board. Oh, should I keep it so the lighting? Yeah. So here's the traditional board. So we have here the 2 inputs and the 2 outputs. And then these double row connectors here are the extension connectors where you can find stuff like even more analog in, more analog out, like 4-channel in, 4-channel out. You can have 16 digital I/O pins. You can have communication buses like UART, SPI, I2C, CAN even, these kind of guys. And we set out to make this. It's kind of, you are asking why we made this, right? It's kind of the secret of the industry, right? And it's not like it's a secret and I will not tell you. It's everybody knows it. you have to listen to your customers, right?
Yeah.
So when the product, it's already quite versatile and people love it, but when enough customers, like high level institutions, even like the NASA guys, I can mention this, they come to us and say, hey, we would love to highly integrate your product. Like some people love the modularity, like they can connect the cable, and when they want to move the Red Pitaya to another project, they just disconnect it.
Yeah.
They reprogram the OS on the SD card, and they can put it in another box, in another project, right? To measure something else, to automate something else. But some higher level, let's say, companies and institutions, and they would really like the high level integration, right? They would love to make the Red Pitaya, to put it in a really tiny space where having the cables would not work for them. So the secret is that we have this mechanism from the beginning, and every time we put out a new model, it's actually driven by the market itself. You know, so if enough people ask for more speed, we make the STEMlab version, which is double the performance almost compared to the popular guy, and so on and so on. So this is how the OEM came to be. It looks simple, just don't place the connectors on the board, but when you are making the board, I will tell you it's not that easy, because the factory has to stop the production line. It has to load different settings on it. And then when you don't have the connectors, it's a little bit more difficult to test the board after you make it on the factory. So you kind of need to have a whole lot of like cost associated with the testing procedure only, because we do test every board that comes out of it. So maybe it's not that easygoing or like innovative for some people not to include some connectors, but when you actually make the board, it's more complex than you would think.
And I guess anything, I mean, if you're going to put that on a drone or in space, any weight saving is a bonus. And
it's already quite light board, it's just a couple hundred grams, or maybe even less than 100 grams. But I would say, my phone, it's 150, so this maybe it's like 60.
Oh wow! So very, very light.
It's very light anyway, and but it does matter. Like when you remove the connectors, like you get them in a separate box, right? When you remove the connectors, you get a little bit weight off. Plus, you don't need the connector on the cable that was connecting to it. And maybe the space that you want to mount it is not enough, and you want to, maybe you also gain a little bit of vibration resistance, I imagine, because if you have a connector and you put it on, I don't know, like a car or a train, maybe the vibration can shake the pin off. But if you solder the wire straight to the board, that's 10 times better, I would imagine. Yeah.
So do you see that one probably as maybe more robust in industrial application?
I would definitely say so. Yeah, I would definitely say so. Yeah, it has to be. A soldered wire will always be better than a DuPont wire going to the digital pin, for instance. Maybe the SMA, if you torque it right, it's not going to go away. But for the digital pins, I'm referring, let's say, more for this. Yeah.
So we chatted yesterday briefly in preparation for this call, although obviously it was meant to be with Guy. But I remember asking you something about, because there's another OEM board from Red Pitaya, you went off on a little discussion about the difference between that one and this one. So can you tell us a little bit about that board and why now there's two?
Yeah. So we have our general product, let's say it's called STEMlab, from Science, Technology, Engineering, and Mathematics. STEMlab 125, which is generally the speed of the ADC and DAC. And then it's a minus, and 14 being the number of bits of the ADC. So it's STEMlab 12514. And like maybe 2-3 years ago, we decided that we have to make a OEM variant, which is actually, so the standard unit like this gets shipped out with a Ethernet cable, with a universal power supply that can plug in all the outlets in the world, and with a SD card and some other small things. And we had some industry, especially industry customers, that were buying these units, but they were using their own SD cards. They were using their own power supplies and their own cables and such. So when you're buying in bulk, like 50 pieces or more, you don't really want to buy the power connectors and then just throw it away, right? So that was the reason why we created the initial OEM variant of the board. And the Bare one is just recently we made it again because of some customers requesting it for a different purpose, for a higher level of integration. Yeah, where the first one is just saving you a little bit of cost. You know, you buy something with all the accessories. This has a totally different purpose. And yeah, we had to have a meeting about how we're going to make it OEM number 2, or what are we going to do. And we went with the Bare OEM because it doesn't have the connectors on. Yeah.
Nice. So in terms of if a design engineer was looking to evaluate this technology, obviously that's its own board. So would it just be a case of coming to ipXchange, asking us about Red Pitaya and detailing their product? Is that the way to evaluate it, or is there kind of something a bit higher level where Red Pitaya would kind of consult with them on what the best board for their project is based on what they're doing?
Sure. We get these questions all the time, like many days, many times per day. So it can be that the customer sometimes know exactly what they want, or they can decide on their own, or just choose the most popular one and they can use it like that. But oftentimes we get questions like, hey, we are interested in measuring, I don't know, audio signals. Can we use your product for that? Or I want to measure antennas.
Okay.
We are making a new type of antenna, and we want to use your unit to measure that. Yeah, I get all the questions like that. The weirdest one that I had to do consulting with myself, it was like one day I get a call from somebody in Africa, in Namibia, and they said, you know, we have a problem here. Lions are eating the people in my village and the animals and such. And I'm working for a company that makes a system that protects the villages. And I was like, okay, wow,
Whoa.
that's some
Heavy.
responsibility to talk about it. And that was a real thing. Apparently, they already had the system in place, but was not as reliable as they would like. And we collaborated with them. We helped them pick the best solution as hardware goes, and they did the software by themselves. Basically, every lion there had like a radio collar, radio beacon on their neck, and there was a network of nodes around the village. And when the signal from these beacons was getting in the range, people would wake up in the middle of the night sometimes and just scare the lions away. But yeah, that was a bit out of the ordinary case.
So what was the Red Pitaya? What was the Red Pitaya doing exactly in that application?
I think it was receiving the radio signals.
Okay.
Yeah. And because it has 2 channels, maybe it helped with the redundancy. I don't know all of the technical details. Yeah. I just helped a little bit to choose the proper model, the proper variant that we had at that time. Yeah. But generally, people can say, hey, I kind of need this speed or this many channels, or generic question would be, can I generate the signal at the same time as I'm listening for signals? or can I add a webcam to the unit, right? Which you can, because it's basically a small Linux computer booting from the SD card, and it has a USB host port. So if you can manage the driver upload, you don't have an issue to configure it. Yeah.
So obviously when this has been a really eye-opening conversation in terms of what Red Pitaya can do, because as I said before, I saw it as kind of like all your instruments in one. So the instruments, they're on an online platform, is that correct? Or are they?
Yeah. I can see why you would think that it's an online program, and actually maybe you can call it that. So the Linux part that's running on the Red Pitaya has a web server on it.
Okay.
So you can connect your PC straight to the unit. You can be on Mars. I don't care. So you don't need internet to actually use the product. You would need internet just like on your phone. When you do the software update, you kind of need internet or some kind of connection to internet. And what else? When you want to report, let's say, a bug, we have a button in the interface, so you can also suggest an improvement or report a bug. Or what else? So you can update the software. Oh yeah, we just like on your phone, we have a application market where even our customers can develop new application, and we can publish them on the market. And when you want to install a new application, again, you need internet. But if you want to use the applications, maybe the ones that exist or the ones that you made, you don't need the board to be connected to internet. The board doesn't fall.
Cool. Okay.
Yeah. So you use let's say you can use the Red Pitaya by default, like in the web browser of your choosing. But not only. Like I said, you can program it in C, in MATLAB, in LabVIEW, in C, in Python. I said C 2 times. Scilabs. So it's really open. Yeah. And we went this route from the beginning with the web interface because this way you don't need to install some software on your machine. And this it's still a limiting factor in a lot of like corporations or factories where they want to control all the software that has to be installed. Or let's say in schools, right? If a student wants to use this on a school computer, he doesn't have to install a whole suite of applications that would make the computer work slowly, right?
Okay,
so browser window, he types the address that is written on the unit here. Like if you want to control it from the smartphone, you just scan the QR code and you're in. You can see all the instruments in the main menu, and with a double click, there you go. You are just instantly accessing the instruments.
Cool. So, I mean, so the internet part is just convenience, really. It's not not essential. Oh, excellent.
Yeah. Well, there's a reason, we went this route to make a remote instrument from the beginning. That's why we have like a screen or buttons or something like that, because you can have the buttons in the browser, and you can have the phone, tablet, or PC close to you and just design your interface or use the interfaces that we provide. But at the same time, you have the added value that you can install this even, I don't know, across the globe, somewhere in China, in some factory to monitor some signals, and you can do the measurements remotely.
Cool. So, I mean, it really does cover everything, because that's basically IoT at that stage.
That's why it's perfect actually for IoT. We have quite some meetings where we decide inside the company, what events to go to, because you have only measurement events. We have embedded devices like event. We have photonic events that we can go, even like nuclear trade shows and events like that. So we kind of have to choose from our budget carefully because we apply to a lot of these events. Yeah. So that's actually very good. That's one of the nicest things about the Red Pitaya.
So for you, what's your favorite kind of application you've seen it used for?
Oh, to be honest, I don't have a perfect, let's say, favorite application. I think maybe the oscilloscope is the most used, that even I sometimes use it on my desk, that if I need something, I literally take the first Red Pitaya that I see, I plug it into my switch here, into my router, and in about like 10 seconds, I can see the shape on if the signal is there or not, and I can do a quick measurement like that. So that's really neat. You know, I don't have like a big oscilloscope on my desk all the time, and when I need some other device, I have to move it away to put another one and do some other stuff. And it's really, really convenient. Yeah.
Cool. Well, we've
Yeah.
covered quite a lot on that, and I've learned a lot. Red Pitaya is definitely a lot more versatile than I imagined. Especially, well, I don't think anyone could have predicted that you'd talk about lions eating people.
I'm sorry if I created this mental image.
That's fine.
But it impressed me like really a lot when I first heard about it, and I'm mentioning on every presentation that I make, you know.
Yeah,
There are
definitely.
like
I can
a
see
couple
it.
of things that I always say about this application that NASA guys did it, you know, it's like quite impressive.
Yeah, very.
And yeah, the students like from MIT that made they had a budget of 500 euro. And what are you doing if you are a student at MIT? You're making a magnetic nuclear resonance imaging device, right? On the desktop. They made a desk size imaging device, and they were looking inside of fruits and vegetables without cutting them open, and they were analyzing the seeds and the stuff like that. So that's crazy that people are able to do stuff like this. And even okay, students at MIT, students in Slovenia, like 2 years ago or 3 years ago, they made a radar on a drone, like before NASA. And they are like students at the university in Maribor, in Slovenia. And yeah, that's really, really awesome that you have the capability to develop applications like this in this day and age with a small budget like that. Yeah.
Cool. And we've talked about budget. What kind of price do they go for?
Well, that's not necessarily the nice topic to discuss after COVID, but I will quickly reopen my page here with the website. I think the lowest that we have right now in our product lineup, it's around 380 something euros. Okay. So you do get the most popular product for this money, like the full specifications, the full speed. And we did have to increase, unfortunately, not a lot, but like everybody else on the market, we were really scared when we got these letters, you know, from the suppliers of chips that unfortunately they don't know when the factory is going to open again. And yeah, that was like the scariest part. However, the company has been doing very well. Maybe, I don't know, maybe the academia market saved a little bit because all the students needed a laboratory at home.
Yeah, and also
right?
like that's price-wise, that's nothing compared to a big scope.
Still, yeah. That's true. That's true. You get
textbooks.
You get a lot of instruments in one box, basically. Yeah. And it's programmable, so you can do your own laboratories. You can do your own applications with it. Yeah. And by the way, for academia, we had teachers making classroom material and then sharing it with us. And this is actually online for free on our website. So if anybody wants to open a new class, all they need to do is just get a bunch of kids from us, and then they can study digital circuits, basic electronics, FPGA programming, and I don't know, digital signal processing. We have lots of stuff like as class of materials. That's really, really neat. And the amount of attention that we get from, especially from academic, it's been huge, especially lately. Yeah.
Excellent. Well, I think we're coming up to the end of the interview, but if you wanted to say 3 points that you think are the strongest points about Red Pitaya, what would you say they are?
I have to think a bit because this is like we have so many points and kind of all of them are good. It depends, if you are the engineer who like maybe not cost, but maybe size or programmability, it's important for you, then this will be the biggest point, So let's say flexibility, programmability would be one. The other one would be performance, because I don't know of some other similar priced package in this classroom of price range that offers this kind of speed of measurements. What would be the third one? The third one, I would have to say it's reliability. Just because we have tens of thousands of units sold, I guess maybe 5 to 10,000 every year, and we have been around since 2013. And I'm also managing the RMA processes, and we are up to the 380 something unit that was returned in all this time,
Wow.
So I would say that's really good.
Yeah. Well,
especially
if anyone's gonna send it to Mars, then it must be pretty reliable.
Oh yeah. And we do have quite decent warranty. The product it's quite good, so why not? I would say performance and then reliability. Yeah. Just 3 points, right?
Yeah. Cool.
Yeah.
Well, it's been really cool to talk to you, Nicu, and I've learned so much. And I think next time I write about Red Pitaya, I'll have a lot more to say in terms of what it can do.
I'm looking forward. Maybe we can do this again. And I will tell you, this happens a lot when we go on the trade shows. I have the chance to talk, face to face to our customers. And a lot of time it's like, hey, yes, I already know Red Pitaya. They already have been working with it for some years. And still, when I'm showing them what is new, they go like, oh, so if I get this accessory, I can have a VNA, like to measure antennas. I didn't know that. And I say, well, yeah, but this is from 2015. It's not like new, and it's applicable to all the product ranges,
Yeah.
So there is always something new to learn. And why I'm saying we can do this again, because we have a few more product ranges that we can talk about. Like we have, maybe you heard about X channel.
No, I don't know that one. Which one's that one?
So X channel, it's again, it was built into the first product. As if you can see here, these two extension connectors here, they look like SATA connectors.
Oh yeah.
X channel system, it's basically a technology to connect multiple Red Pitaya boards.
Oh no, I have seen this because I think Micha had 4 of them all connected together, maybe.
That was me. That was me on the demo. That was me. Micha had 7 ones to showcase different variants of hardware. And one of the boxes that I had was this box with multiple Red Pitaya units, and they were connected with the SATA cables. And it's a really nice for scalability because compared to previous traditional instruments, it doesn't have a data bottleneck, right? So those SATA cables, they only transmit the clock and the trigger information, and the actual measurements, because this is a problem, and this is why we have Ethernet connector. When you have so big speed, so high speed, it's like a lot of measurement data, right?
Yeah.
So every unit has the pipe the gigabit Ethernet pipeline to get the data out of the system. It's not like you have one master and multiple slaves, and then the slave units push the data to the master, and then the computer is connected to the master, and usually there's a big data bottleneck there.
Yeah.
So that's one thing that we can even discuss more about it, how that technology or model came to be. We have the STEMlab, maybe you heard about it, which is a bigger unit with double the performance almost in every way. And yeah, we have this Bare OEM that is quite new, and we have the low noise version that we come out just because, again, we had some research institute customers that really wanted the higher. But I'm dragging your time, and I'm really sorry for that.
No, don't apologize. I think we will have to do this again. Or you'll get to do it one with Guy as well, which would be good.
Oh, that would be great. That would be great.
Yeah.
Either way. Yeah. I would be happy to do it. Like some heroes in the movies. I could do this all day.
Nice.
Yeah.
Well, thank you very much, Nicu. Anyone who wants to learn more about Red Pitaya, you can head to the ipXchange website. We'll do a write-up on the new the Bare board. And it's been fantastic to talk to you, Nicu. And yeah, we'll have to do it again sometime.
Thank you very much for the opportunity and for your time. And what can I say? That's really really nice, versatile board to have around and to play around. And if it allows you to make the most interesting projects, that's a really very big thing for us that you are doing this this call right now. And I really appreciate it. And I thank you very much for it.
Cool. Thank you. Until next time.
Yeah. Ciao, everybody. Bye-bye.
So, from intentions of going to Mars, already gone to space, protecting villages from being eaten by lions, I don't know what other limits there are to the applications for the Red Pitaya board. So yeah, we've got a new version without the connectors, so you can put it into even more compact deployments. Let us know what you're going to do. Apply for it on the ipXchange website.